Good morning students. Welcome to our online video class of chemistry. I hope all of you are doing well and safe. In previous section, we had discussed about scientific notation. What is scientific notation? It is the simplest way to represent small numbers and large numbers, and also discuss about some rules of scientific notation. Today we will discuss about significant figures and also dimensional analysis.
Students, we have learned about scientific notation in previous section. Today we are going to discuss about significant figures. Have you ever heard about the word significant figures? Then what is the importance of studying significant figures in chemistry? All this we will discuss today. Suppose when we buy eggs, bananas, chairs or chocolate, etc., we ask for an exact number and we will get the exact number of that. However, when we try to measure the height of a person with a measuring tape, it may not be possible to measure the height exactly. The difference in two situations arises because whereas chocolates or egg are measured by a discrete variable, there can be 5x or 6x but nothing in between. That means in the case of egg, chocolates or chairs, we don't get 5.5x, 6.5x and 6.6x. We only get the exact number of that. And in the case of height is measured by a continuous variable. It can be 160 cm or 161 cm or also anything in between. For example, it may be 160.5, 160.12, so on. Let us suppose the height of a person is in between 160 cm and 161 cm. Then a measuring tape with centimeter marking can only tell that height is greater than 160 cm and less than 161 cm. That is the uncertainty in the value of height will be plus or minus 1 cm. Let us take another example. The mass of an object measured using two balances are given in this picture. And the mass of the object is obtained using platform balance and it's come out to be 9.4 grams. On measuring the mass of this object on an analytical balance, the mass obtained is 9.4213 gram. If you observe the data, you will understand the mass obtained by using analytical balance is slightly greater than the mass obtained by using platform balance. Therefore, the digit 4 places after decimal in the measurement by platform balance is uncertainty. Therefore, every experimental measurement has some amount of uncertainty associated with it because of limitation of measuring instrument and the skill of person making the measurement. And the uncertainty in the experimental or the calculator value is indicated by mentioning the number of significant figures. The total number of digits in a number including the last digit whose value is uncertain is called the number of significant figures. Before going to study about scientific figures in detail, you have to know what is precision and accuracy of a measurement. Precision refers to the closeness of the measurement for the same quantity or the true value. And accuracy is the agreement of a particular value to the true value of the result. Let us understand what is precision and accuracy in detail using an example. The given data contain the results of measurement done by 3 students. And the true value of the result is 2 gram. Student A take two measurements and report the result as 1.95 and 1.93. These values are precise as they are close to each other but not accurate. Another student B reported two values as 1.94 and 2.05. These two values are neither precise nor accurate. And the student C repeat the experiment and obtain the value 2.01 and 1.99. These values are accurate as well as precise. To determine the scientific figures of a number, we have to follow certain rules. Let us study one by one what are the rules and its examples. First rule is all non-zero digits are significant. Let us look some example of that. All non-zero digits are significant. For example, 217. In this case, the number of significant figure is 3. There are 3 non-zero digits here. In the case of 2.17, the number of significant figure is also 3. Here, decimal point is not relevant. The second rule is zeros preceding to the first non-zero digits are significant. Such zero indicates the position of decimal point. For an example, 0.03. This number has significant figure 1 and 0.0052. The number of significant figure of this number is 2. Third rule is zeros between two non-zero digits are significant. The zero lies in between two non-zero digits are significant. In the case of 0.302, how many significant figures are there? 0 is lying between 3 and 2. Then there are 3 significant figures in this example. And in the case of 2.005, the zeros are lies in between 2 and 5. Then how many significant figures are in the case of 2.005? 1, 2, 3, 4. There are 4 significant figures. And let us look at examples of zeros at the end or right of the numbers are significant, provided they are on the right side of the decimal point. The number of significant figure of 0.200 is 3. If there is no decimal point here, the terminal zeros become non-significant. In the case of 100, how many significant figures are there? 1, only 1. But in the case of 100 point, there are 3 significant figures. And in the case of 100.0, there are 4 significant figures. And in the case of 1.0 into 10 to the power of 2, the number of significant figure is 2. In the case of 1.00, what will be the significant figure? That is 3. Next rule is exact numbers have an infinite number of significant figures. Example for exact numbers having an infinite number of significant figures. For example, in 2 balls or 20x, there are infinite significant figures as these are exact numbers and can be represented by writing infinite numbers of zeros after placing a decimal, that is 2, equals 2.0000 or 20 equals 20.000000 so on. What are the rules for determining the number of significant figures? All non-zero digits are significant. Zeros preceding to first non-zero digits are significant. Such zero indicates the position of decimal point. Zeros between two non-zero digits are significant. And zeros at the end or right of the numbers are significant, provided they are on the right side of the decimal point. Next rule is exact numbers have an infinite number of significant figures. Next we are going to discuss about addition, subtraction, multiplication and division of significant figures. In the case of addition and subtraction, the final result should be reported to the same number of decimal places as that of the term with the least number of decimal places, or the result cannot have more digits to the right of the decimal point than either of the original numbers. For example, 12.11 plus 18.0 plus 1.012 equals 31.122. In this, 18.0 is the term with the least number of decimal places. 18.0 have only one digit after the decimal point. Therefore, the result will be 31.1, one digit after the decimal point. Let us take another example. 16.182 minus 4.2563. The result will be 11.9257. This example, 16.182 is the term with the least number of decimal places. This number has only 3 places of decimal. In the case of 4.2563, there are 4 decimal places. The final result must be reported up to only 3 places of the decimal. Then the result becomes 11.925. Multiplication and division of significant figures. In these operations, the result must be reported with no more significant figures, as in the measurement with a few significant figures. While reporting the result of multiplication or division, the final result are reported to the same number of significant figures as contained in the quantity with the least number of significant figures. For an example, 2.5 into 1.25 equals 3.125. Since 2.5 has 2 significant figures, it is the quantity with the least number of significant figure. Then the result should not have more than 2 significant figures. Thus, it is 3.1. Matching the result to required number of significant figures, we have to follow some rules for rounding of the numbers. The first one is, if the rightmost digit to be removed is more than 5, the preceding number is increased by 1. For example, 1.386. If we have to remove 6, we have to round it to 1.39. If the rightmost digit to be removed is less than 5, the preceding number is not changed. For example, 0.334. If 4 is to be removed, then the result rounded up to 4.33 because 4 is less than 5. If the rightmost digit to be removed is 5, then the preceding number is not changed if it is an even number. but it is increased by 1 if it is odd number. For an example, if 6.35 is to be rounded by removing 5, we have to increase 3 to 4 because 3 is an odd number. If 6.25 is to be rounded off, it is rounded off to 6.2 because 2 is an even number. If the rightmost digit to be removed is 5, then the preceding number is not changed if it is an even number. Next we are going to discuss about dimensional analysis. What is dimensional analysis? While doing any experiment, any calculations, we have to convert one set of units to another units. This can be done in a systematic way by a method is called dimensional analysis. When calculating, there is a need to convert units from one system to another. The method used to accomplish this is called factor-Lappel method or unit factor method or dimensional analysis. For an example, how to convert 10 minutes into seconds? We know that 1 minute equals 60 seconds. Or we can write it as 1 equals 60 seconds divided by 1 minute. Then 10 minutes into 1 equals 10 minutes into 60 seconds divided by 1 minute. The minutes get cancelled and we get 10 into 60 seconds, which is equal to 600 seconds. Here we convert minute into seconds. Convert one unit into another. This is one of the dimensional analysis.